Good afternoon, everyone. Welcome to this edition of the NITheCS Colloquium. This afternoon, it is a pleasure to have Christine Darve with us from the European Spallation facility. Oh, sorry, in Sweden. Yeah. Christine started her academic career at CERN in Geneva, and afterwards she spent some time at the Fermi Lab, US. Is now European Spallation source. Yeah? She's not only interested in her main job, which is design accelerators, essentially, yeah, but she also has a weakness for education and outreach. Yeah? And among many things, she's one of the co-founders African School Physics, which took place last week in George. That's why we managed to get her to visit us in Stellan. Christina is also involved with the Forum of International Physics of the American Physical Society. In fact, she's chairing it. and today she will give us a very interesting talk about how to be digitally educated in a world that only works following big projects. Yeah. So Christina, thank you very much for being with us today. We're very happy that you are here. We're very curious to listen to your presentation. Thank you very much. Please.
An introduction. So indeed, so if the sound is okay, so and then again, forgive my Franglish. So if there is any question, so we can maybe either interrupt or at the end repeat some of those things. But I think you have the slides, so it will be easier. So indeed, today I will go a bit beyond as well the borders of those large projects that I've been involved with, and as well to try to see how this educated world can connect. So the outline will be to find and describe this ecosystem that I call between the education, the research infrastructure, and the industries as well. And I will bring as well you towards as well those continents where I've been working. So in Europe, in Africa, and in America. And I will so in Europe, so describe this European spallation source and the different connection as well that brings, like at CERN, so the possibility to be beyond those borders. And in Africa, so I will describe the African School of Fundamental Physics, its application. So this is what we started indeed in 2010 here in Stellenbosch. And in America, the Forum of International Physics, so where we have quite some activities that I want to share with you too. And I will describe so how data as well can bridge the different communities. Finish finally with different tools that like those MOOC possibility to massive education. So I always, and I like the idea of getting to the, so 1, 2, 3, 1, 2, 3, so I try, so this paradigm as well. So that's an interesting aspect as well to look how we have evolving as well between the different revolution and the different evolution of the society. So this industrial economy that is nowadays, so it has evolved from science, technology, business, and organization. Each time getting more possibility to learn. And for the revolution, the information revolution, you know that science, thanks to those solid state and discovery, get possibility, for instance, to look at how World Wide Web could then erupt in terms of new technology, different media that get as well into this possibility to implement it, and now in our society. So for the European spallation source, this is a bit the same, but looking at the molecular economy. So if we look each time this ecosystem that I described before between those research infrastructure, education, and those industry, how to make this happen, how to have material and life science as well, those different facilities that are key for this economy. That's more like the context. And now if you look at the research infrastructure, big research infrastructure, everywhere we need as well those to be able to analyze and get our different so measurement, whether it is from our research or is to improve the society. So here I choose the example of the European spallation source, but like at CERN for fundamental research. So this is like a microscope into the matter to try to understand how the fundamental is working, how we can go from the micro to the macro and understand the universe. And all of that is really to find ways as well to transfer those information from this knowledge to the academic, as well through the industry, so that we can have this organized and structured way to serve the society. So the case of the photon and the neutron, so looking at the European spallation source and looking at light source, like potentially as well, one as well in Africa. So for, you see here, for instance, this Buddha, so this is how you see it with your eyes, but then if you had some X-ray eye, then you would see that those X-ray, like with the light source, will knock the different electron at the periphery of the nucleus. Then you will get this image. So meaning that it's only the heavy, so the large C that can get possibility be well described with X-ray, like you know this for a long time. So then with neutron, if you had neutron, then you would get possibility to go across this electron cloud and directly see also atoms that have a low Z. This is the case of the hydrogen. So this is why, for instance, for the case of life science, where you have like 50% of biological macromolecules that are made out of hydrogen, neutrons are really useful. And here you see, for instance, with X-ray, how a molecule of water would look like and how with neutron it would look. This is, for instance, the bonding of hydrogen and how, for instance, you would see that this Buddha had inside as well. This is actually a message that was hidden. So that with the papyrus, so you can see it with neutron, but not with X-ray. We can discover a lot of magical secret as well, so thanks to neutron. But then could it be more source as well in Africa or for Africa's research? That's also some of the questions. So I put little question like this along the line so that you can think as well, and potentially we could discuss this later on. So now, a source of neutron. So this one that we have in Europe, so it has been already one in operation in Japan and one in operation in the US, so in KK, and in G-Park, sorry, in Japan, and in Oak Ridge for the USA. So it works by accelerating proton, and this is to get high energy neutron instead of a reactor where the flux would be too low. If you accelerate proton, which are 2,000 times heavier than electrons, so you need a large accelerator or large magnetic field to be able to do that. So you need superconductivity, you need really expansive device, I would say, to be able to bring your photon up to more or less so the speed of the light when it hits the tungsten here. So this is a target to be able to generate high energy neutron that will be moderate thanks to hydrogen, to water, and then get your beam of neutron to be able to analyze so the matter and get a possibility to better understand so life science sample or different material and how to improve them. So this European spallation source is what we are now building. So in Sweden. So this is here in Lund, the very south part of Lund, really close to Copenhagen Airport as well. So that's the reason as well of being there. And you see that so all those people so have been gathered from around the world. So we have 13 different country members that support half of the budget, and we speak about 1.843 billion. So that was how we started. With those 13 countries, half of this funding is coming from in-kind and those member countries. So we are about 500 people right now, and we are going to then build through this in-kind collaboration, this source of neutron. Oh, I put a lot of links as well in this presentation if you want to see more. So this is 13 minutes, so I will not go through all of that. But you see here one of our scientists so explaining with those neutron eye what neutron can be used with. And we have different grants, so European grant as well with 2020 that permitted us to get so some more understanding looking at how to transfer this knowledge into industrial way of using, so advanced material or more source. So here, how this innovation as well give raise some new potential. You can see much more information. Again, I'll not go there, but you know that it exists, and if you want to look more, you are, welcome to do so. So now connecting to also South Africa, I wanted to emphasize here one of the other grants as well with the Horizon also 2020, how this Brightness 2 gave possibility to connect South Africa with the European Spallation source back already now since 3 years, so it ended up. But we had so collaboration from iTumble Lab and from the NITheCS, and possibility to think in terms of what could be synergies as well, and how could we evolve towards common work. So fortunately, COVID arrived, and there was, I think, because of also this difficult possibility to travel, some activity that could not happen, but different meetings have been so ongoing, and then we are still now with different researchers, for instance, here from UCT, having possibility to develop mainly in the field of deuteration, which is one of the techniques to analyze so between deuterium and then the hydrogen atom, more more interesting things so on life science or in biology. Also from ISIS, so which is one of the source of neutron in the UK, pardon. So a lot of different development are ongoing. Zoe Fisher, who is from South Africa, is so one of the promoter from all of this effort. So again, can it be some more connection as well and synergy between both of those institutes? This is a large project. Now I will go to Africa. So I'll come back here. So actually, after 12 years, while here, so showing with some pictures. So when we were young, so some of the different people that you may recognize. So here as well, but since with so Professor Asvandini Mukonga, who was at that time so showing us Cape Town, and some of the participants whom 12 years later as well as some of the alumni helping us with the preparation of the school. So you see here in 2010 in Stellenbosch, so this is housed as well, and thanks to the NITheCS that we had the possibility to start. It was a startup of this school. And so we had another school that happened. So then 12 years later, so it was supposed to be because of this International Year of International Year of Basic Science and Sustainable Development, to have South Africa as well to host. And this time we went to Port Elizabeth, and thanks to the Nelson Mandela University, where so Professor Asvandini now is so sharing the science. The Dean of the Science Community. And last week, so this is also indeed, as it was explained by Francesco, the reason of this conference that we had in Georgia, that we're gathering, so the people that you see here, so on this picture, and again, for women in physics as well, so a little card, so with Professor Momse Diale, so who is helping a lot, or giving possibilities as well to women to be more engaged in the physics community. So the mission for the ASP, so this is, so as it shows here, a non-profit organization that we then kickstarted in 2010, thanks to the NITheCS. It's really organized in a family way, I would say. So thanks to different students, at that time, we're not students anymore, but we had gathered different institutes working mainly between CERN and Fermilab, and getting possibility to get from the ICTP as well, and the different institutes. We had 24 different institutes providing some support, financial support, who gave up to, so we had at that time, 76 African students who were coming, in Stellenbosch. So the idea of this school is really to bring capacity, so in Africa, on the continent, and have possibility to share this knowledge, and looking at how and why also particle accelerator can get a possibility to better understand so this science and this society around us. So the different technology. So it contributes to an equal access to the knowledge. So again, possibility for the African student who otherwise could not be so visiting or attending the different school. To be every 2 years reconducted in different locations, so within Africa. So that's the idea, to have a more equal distribution as well, and an easier access for everyone. Initially, we wanted it to be whether in French or in English, but we kept only the English version for somehow indeed the scientists. So it's difficult to have some French-speaking scientists at a level that we want to be able to exchange. And you can see much more information here. So from the summary that Monia Lassiri gave us last week, or the presentation that we gave in Wits University in June 22. So the committee, or when we started all of that, so you see this is the different committee members. So with maybe journalists that you recognize here as well. So we gave indeed in 2010 one also public lecture. And Dobrowski, who is also from South Africa. And so with Bobby Aksaria from the ICTP, Steve Mwanza, who with John was really the one bringing the idea as well to develop something that had this capacity as well in Africa. So Steve was the director as well from all this initiative. Professor Fernando Ferroni joined us later, but so all together, and especially now with Ketavi, who is leading. So I was the main organizer for the very first edition, starting up everything, making sure that it was okay, but I'm not African, as you can see. So Ketavi has really the possibility to now lead it and thanks to Brookhaven as well, in the way that we know now. So that's the initial team, but the committee is much more than that. So we have a local organizer committee, depending on the country where we go. So we have this local committee who is really providing essential support. Like in this case in South Africa, so Asvandini Moronga was really the gatekeeper, I would say, for the success of the school. The impact as well, every session and every edition. So we have a summary of what we have, all the activity that were provided. We are in an advisory committee gathering also all the different speakers and the people who have this knowledge from the different university and institute across the world. This board of trustees gave possibility as well for the fundraising and the different legal aspect. So we have an established now organization and the different spin-offs. So this is also what is important for following up and to have the sustainability as well of this school. So here I summarize all the different schools that we had so far. So those 7, some were online, so because of the COVID. And we really get the possibility as well for having, so as you will see here, some really dynamism between the student and between the professor. It's something which is in life. And this is what is really appreciated, to see this every year, a difference as well in the program. You can see when it was online, so in 2021, this is when we had a lot as well of online capacity. And again, this is what I think the advantage as well of this online aspect, to massively reach out outside of the number. But student program, this is what we focus on. It used to be 3 weeks, so this is how we started everything. Now we tune a little bit the program so that it's 2 weeks of intense school for the student. But we had another 1 week for a conference. So more or less now, this is why why I'm here as well, and getting possibility to have a follow-up of all the different alumni students that have been doing all those editions, now giving possibility to present their work. So they have now become, after they graduated from the PhD, they are part of the academical world, and they can be everywhere as well in the world. So again, spreading the word, giving possibility to bring back as well in Africa this knowledge. So again, research infrastructure is always what is missing. So one of the things, again, important here is how to teach, but how to also develop the capacity with infrastructure. I come back on that because I think it's important. So teaching at every level. So this is also what we have expanded. So with teaching teacher, so that they can by themselves as well have the different tools to be able to teach their own student what physics is and how to motivate. Because if you go, I mean, outside of this world, I mean, it's kind of difficult to understand why would they study physics if they are in, in a township or in places where it's more or less mathematics first and physics and how to understand the methodology. So this is what also is important for those teachers to see. So the learner program, so meaning that we go directly to some of those high school and give possibility to bring, and now this is hundreds of young students that give to understand a bit physics with the cosmic ray. You can see this as well. And for them, this is exciting them as well from understanding from the cosmos and everything you can do thanks to particles and thanks to accelerator as well. So we have this forum as well, where it's more for the policymaker, try to understand how to live something as well in each of the country where we go. And so this conference that I mentioned before, so it's also essential for also bringing knowledge so from and through Africa. So we have we try to have also a lot of lectures from Africa and from the country where we are. So the mentorship program is also extremely important for all the different alumni to be able to follow up as well with the different committee, the different lectures that will then give them the possibility to be part of so their own team. The different topic of interest. So it's really physics in a nutshell, I would say. So it's really difficult because of the different level of the student, but we want up to 60, 80 different students. So this is why we had initially in 3 weeks, theoretical physics, experimental physics, and different application. So that's how we started. And we kept so this kind of analogy in terms of how the particles and application. So it's really fundamental, so from the nuclear, the elementary, so all the astrophysics, which in Africa is an added value as well. So that's what we looked at and focused on, the new technology as well. Different light source and their application, so all the solid state and all the different atomic and molecular physics and the photonic as well, which is extremely important. And of course, all the environmental aspects, so the renewable energy. So this is here as well with depending on the country, so more of the quantum information or quantum physics, like in, for instance, Marrakesh, they have a strong interest for that. So high-performing computing. So since 2012, we always have those sessions which give possibility as well to relate to data, and that's an important aspect, so to stay also connected in one side. And all this engagement, so all the possibility as well for physics education and for getting also early career, showing them how to be maybe also more proactive and to really see how to evolve in the society. So also this online course, so because of the pandemic was again like looking at the positive side, so it gives us the possibility to transform our teaching into a more digital world, so which I think is an asset because all of that is sustainable. So again, coming from the world of photon and photon, so I was trying to get so different courses, a mini series on that, but you have here all of the different presenters that would have given those 3 weeks that recorded their own classes, and you can find all of that as well now online. So now the free conference that we have, so since 2016, so we had the online one that we mentioned, that you can see again all the information from. And you see all those different links, and it was published as well in the Review of Physics, so peer review. So it's also getting possibility for knowing more. And you see this article as well here that was showing also how we use the gather town. I don't know if you know that, but it means that even for poster, we can be in person with the digital avatar, and that was really making as well something really interesting. Again, to reach as well for our own knowledge, those technology that can be quite interesting. So looking at the policymaker, how every year we connect, and you see here, for instance, indeed with Daniel Adams, so the possibility for the government to be involved with in 2018 as well with Rob Adams as well with SKA. So again, looking at South Africa, so that were two important moments where we try to connect as well and see what can also be in the society. You see in Ghana, for instance, in 2012, with Herman Winnick speaking about the idea as well of this African light source, and with Lucas Serafini, who is looking at the compact accelerator, but who is now together look more in terms of bringing as well some more development for this African light source, or for more infrastructure here in South Africa. I want to emphasize as well in 2014 in Senegal, we had this forum run with Amadou Touré, who is the former secretary of the ITU, the International Telecommunication Union, sorry. He was Secretary General at that time for 2 mandates, and he came as well, and you can find his remark there. He sponsored as well students from the least developed country, women as well, to give possibility to start something as well for their career. And he's also the founder of Smart Africa, so located now in Kigali, but having transforming Africa. So that's the connection as well, and the ICT world, which is essential. So I believe that he's really at the source of a lot of the development we have there. So I will not pass, all of that, but again, it's a lot of policymakers that can see something staying as well in those countries. So now I go to America, another continent where I've been working there for 12 years. So with 1 feet in Europe and 1 feet in America. But the Forum of International Physics, this is where also now I stay connected with. So by being the chair indeed, and I comment as well from the Committee of the International and Scientific Affairs, so where I'm part as well, because they also provide possibility for more capacity. So I show here, for instance, this forum and the different activities that we empower. So you can find, for instance, information looking at the different programs, the distinguished student that I will show later, but again, to share also with your community, because we don't have enough, I would say, applicants as well from Africa. And I will emphasize a bit later on this physics matter. So this is how this page looks like. And you can see here, we had, for instance, also for the Oppenheimer, a special forum. You can see all those information in that webpage, and how to find ways as well to engage. So that's what you can find. And you'll see the next presentation where you can register from that page. So advancing the knowledge of physics and its diffusion by fostering cooperation and communication among physicists of all countries, because in the American Physical Society, 30% are not from America. And for instance, I was not American also being there. We are nominating the different fellows and providing award as well. And again, you have to be an APM member to get those fellowship. And for instance, we gave to Ketavi, so Assam again, one of those fellowship. And you can see here all the different activities, all the regional, so engagement. So thanks also to the CISA, if you look at those different things. Also to be able to reach out, so a larger community. So for every student, so the first year is free. But for the matching program, which applies to also different countries, so in Africa, you can have, the student can have up to 4 years of membership free, and a really low cost after that. So you can then receive or have those distinguished students that will, if they apply for those criteria, give possibility for them to attend so the March or April meeting in the US. So every year there is the March meeting and the April meeting. For instance, last year we had 13,000 people gathered in Las Vegas, and that was this very one. So you see in Las Vegas, 13,000 people, 30,000 physicists. And so with the FIP, so we organize 2 sessions there of so 5 persons speaking. And we had a focus also on the IUPAP. So IUPAP, so we stand for the same spirit, the same mission as well than the Forum of International Physics, International Union of Pure and Applied Physics. It was the 100th anniversary, and then we had invited so the different so president, we had also attending, so 2 presidents of the APS and 2 different award winners. We had a large-scale scientific facilities and diplomacy session, which was also gathering people from so from CERN or from all the places that can make a difference at sharing information, like the former, the current so president of the CERN Council, but as well for the so African light source as well, Sikazi Muganza was presenting in that session too. Just some example, but again, you can give and see there more information. I can also share the slide because I collected everything. So, and for the younger as well, and that was on the Women's Day actually, and we get possibility as well on the 8th of March, yeah, to have so the younger perspective as well. And there, same thing, we had the African strategy represented by Munia Lasseri, who was also in this African conference, one of the main organizers. And in April, so that was quite a smaller session, like every April meeting, but giving possibility as well to come back to this physics matter that I will explain now, with also so Ralph Royer, or the different person who changed, or the president of Engineers Without Borders. So we had also Physics Without Borders, so it was really a panel of scientists, so changing and helping to change and adapt the world. And then as well, how with the energetic crisis, we focus on how accelerator can be used for that. So fascinating time as well by exchanging with them. And we had an online session as well, gathering the different women, and that was in the Sesame in Jordan, so organized so by so Gian Kamer, with gathering, I mean, some really impressive women. So again, the ABS is trying to connect and to strengthen the different activities between the different units. So you can see much more of that in those articles as well that are important. So communication, so this is what we try to do also thanks to our newsletter. So newsletters are accessible from everywhere, even if you're not a member. And here I was trying to put as well, so emphasize in the African so arena as well, how with this first school, but also along the line, how we can bring different activities. Now we have as well the African Physics newsletter, which is sponsored so with the APS. And we have so Stéphane Kenmore, who is from Cameroon, and who is helping now, being also the editor-in-chief of the FIP. So he will help gathering much more and giving much more visibility in terms of what Africa can do. You have here so the Twitter and the Facebook, but in terms of know-how and in terms of communication, I would say that we have really experts with lightsource.org and CERN Accelerating Science who help us a lot to communicate. A lot of different work. So now looking at so the physics matter. So we have here much more that can be looked at. So through and from the Sesame. The Sesame in Jordan is gathering 8 different countries, and we try to invite them to discuss the different scientific case around the light source. But we want to expand as well to much more popular science, so to developing community, but also to find ways to engage and to enable. So I will go really, I mean, yeah, I will not go quickly to all those 35 because it would take too long, but then you can see and watch everything by yourself. It's all recorded on YouTube. It may be 1 hour, but this is much better than some boring movie, I can tell you. And you can learn much, much more. It's not as scaring as well sometimes. So, but this is really a way to reach out and to find as well interesting topic. And then we have a lot of those topics around photon and neutron, but much also looking and connecting to environment and medicine. So what is important? And really the next one, you will hear much more about dinosaur, and you can see, I mean, I can share also later on Here we have an expert also who was also quite often on the BBC and who can explain everything, how light source can be used as well to better understand the life of the dinosaur, or how with Carson Wells as well, how you can understand from Star Wars the real or the wrong, what is right or wrong in terms of science. Then it's really entertaining. So those highlight, I will also discuss, for instance, really quickly, this accelerator-driven system, which was providing, thanks to Professor Han He from China. Live from China, we had him explaining how those accelerator-driven system can work. Smaller system as well that can as well empower and give much more energy as well to places where the load shedding could be an issue, I would say. So, and a lot of connection as well from his life as well, partially as well in America. So all of that is connected. The African light source presented by Professor Connell, so he as well. So we had this session. We had from the IUPAP also a full session dedicated to that. So sustainability, because again, everything is recorded. And then we had the anniversary, the 90th birthday, so 32 degrees of Professor Herman Winnick, gathering 17 different persons from the Sesame, from, for instance, Adayana, so Nobel Prize of Chemistry in 2009, Christopher Smith, and we have 3 directors that have been connecting to the Sesame Council. Now, to bridge those different communities, we have data. And data, this is also with in Stellenbosch. So you have evolved towards theoretical and computational science. And this is, I think, one of the keys. So that's why I wanted to also discuss this FAIR principle and open source that we could apply. And of course, data are everywhere. So if we look at the case of the ESS that I was presenting at the beginning, so from this accelerator to this heavy metal target, so the tungsten, or the instrument, we gather all those data thanks to the DMSC, so Data Management and Software Center. But again, how do we structure everything? So if we look for the case of the accelerator, and you can see much more information there. So by Adnan Gribi, who is from Galin and CNRS leading this effort, we have built up a network, and we are applying now also to a call. So how could this call, for instance, could be with some potential connection as well to Africa. So here, this is the network that we have already. So with more than 19 different partners institute from 9 different countries, 18 partners from 9 countries around Europe. So this is those that can apply. Those with the red are already part of this S3 research infrastructure. Need only 3 also to connect, but you see it's really AI machine learning is something that is calling and resonating. So we try to find a way through this network as well to understand how to guide, how to structure everything, keeping this transversal approach as well and this open mind way. Again, look at the data maybe from what was in the link if you want much more information, but you will see more or less indeed from you would have people that would be expert with the curation aspect and some that would be more advanced with all the different, for instance, optimization function or the different way to detect abnormalities. So this way of working is what this teamwork as well gives possibility to develop the different as well simulation to try to be much more accurate for the result that is needed. So again, how to together find this adaptive solution, building a prototype for a smart accelerator, I could say. So natural language processing is an important aspect as well, because of course, language is what we use as well as a tool. And I would just show here, so based on this brightness project, some of the work completed by colleagues from the Netherlands, very effective as well to within few seconds to have the answer of your problem. So you can use Google for sure, but if you want a smart answer, I would say, so you have, so those techniques give you some really pertinent answer quite quickly. So now looking at the digital aspect a bit more, so with those loops, so I mean, digital towards digital, so it has to be first from in person. So I just mentioned here this advanced school where, so in Sweden, between the French and the Swedish government, so with the embassy, so we are looking at how to educate more of and teach more, looking at what those photon and neutron source could provide. So it's like topical. So school, we had one in 2019 based on environment and materials, so the hard X-ray as well. And now in 24, this life science. You can see there more or less as a model, and all the course could be accessible, even if you can might not have those 30 students as well, being able to attend if they're not French or if they're not Swedish. But nevertheless, this is an example, and this is model of what we could do as well as a bilateral effort. So from the European part as well, another grant that was for this innovation for fostering accelerator in science and technology is challenge-based innovation. So that was possibility to bring the multidisciplinarity as well together. So students who were in engineering, in physics, in economy, or in communication, and lawyers as well, working together by themselves to develop a project that could be useful for environment. So this is, and the solution are quite interesting. You can see much more there in those articles. So this is what Europe also enabled, and this is here what was summarized also at the APS, so with the FIP, the session that we were mentioning, and I was mentioning here those younger talent. Now, how those massive open online source can be as well used for tools. So depending on the level and depending on the existing program, we need to be complementary. We need to really to have possibility not to reinvent, but to build up as well those know-how. So in Europe, the Tiara for the accelerator is organizing and structuring a bit. So this way of developing the different schools. You may know the accelerator school, so the CERN accelerator school or the JUAS, which are quite an advanced level. So what we wanted to do was to get possibility to teach to a lower level. And this is why the area and this Nordic Particle Accelerator program was developed. But based initially on a school, so that we develop as well the team, so that as you can see there, we can choose the right teacher, the person who could really provide information. We look also a bit also regionally, because of course the northern part of Europe was maybe not having, like at CERN, the same visibility. So Max for NITheCS, so the light source and the neutron source in Lund, so giving possibility to have more light as well on the synchrotron use or the different spallation use, but as well CERN, and then development for the future collider, for instance, or a lot of really good speaker as well. This was divided in 3 different MOOC that everyone can attend for free as well. If you want a certificate, then you pay 80 euro at the end, but that's giving possibility to have your equivalent ECTS by and with the university. The second MOOC was much more fundamental technology, how you would build an accelerator, what are the different, so introduction to the RF, so the cavities, the magnet, the instrumentation, the vacuum. How do you, this is really the base, how do you develop that? So again, to have a kickstart to build an accelerator. And then application, so medical field is an important one. So this is why we had looked at the photon and then the proton therapy. And you see there, so we have, so this is the distribution of the different learner involved. This is how the course look like. We have those little movies. We have possibilities. So thanks to Coursera, we have this sustainable system. So you see, it gives you and it guides you as well through the, when you have possibility to follow up. So all those courses, the different material available. And we have reached now about 18,000 students, so learner we call as well, so across 100 different countries in the world. So again, this massive and this digital aspect and capacity, that's what we believe on. So now again, material to be able to develop as well different accelerator here in Africa, also the compact neutron source. Open question. And I will finish with, so this grant, so this is the follow-up grant, trying to teach teacher now what an accelerator are, like more than 1/3 of the different Nobel in physics and in chemistry thanks to accelerator. So this is a lot of things. There's more than 35,000 accelerators as well in the world. And we don't know all of that. Most of them are used in the industry and some in the medical. But again, we try to explain to students as well, or to learners, how they can be interested by that, by seeing that the light source, for instance, with the dinosaur can really bring you as well some interest there, or how with the cosmos particles can be as well understood, how the different life science can be understood thanks to neutron source, like I was showing with the DSS. And all of that is done in a very professional way. So thanks to Brussels, so with the Euro, so SchoolNet, or the promo pack, so is available there, but everyone in the world as well have possibility for the teacher to gain scenarios, to exchange as well among the different teachers, and to give possibility for inspiring movies as well. That's some of those things that we are developing, so thanks to this grant. So again, everyone on the 16th of October can apply and can participate. So it's really, I think it will be really important as well for those STEAM education. So I just summarize here, so what we have, and it's really what I see in line with all the work as well that you're doing here in Stellenbosch and with the Nelson Mandela University. So thanks to Professor Advandini Mukonga. And I just put here, so the link that summarize as well all the work and the internship so that have been provided so in Africa. Again, this is a good thing. When it's digital, then it's worldwide. So the implementation of this ecosystem, so as a conclusion, it's really take some research infrastructure, but you can, again, those research infrastructure can be as well around the world. You can see here, I find it's really inspiring at CERN how accelerator can be really like some of those tools for discovery. The education is fundamental, really the research as well for the development. And now from the digital point of view, I mean, there is no boundary, let's say. And how can this innovation and all these different accomplishments can bring as well to the industry and the society all of that? So how can we, back to this very first curve, get possibility to implement all of that in our daily life? And of course, this is an ideal, but then how to transform as well this society? It's really by perseverance and by giving possibility to educate people around us and not to be afraid of physics, because physics can be just also like playing and getting to learn by playing. This is what this MOOC can show you. And then this is how I would conclude, indeed, at every level to get possibility to transform as well and transcend those boundaries. That was maybe a bit long, but remember that there are links everywhere. And then if you have the slides, so you can refresh your memory and go deeper as well into this, as we say there, so the digital exploration, I would say. That's just, I want to, we'll finish by that, so thanks for your attention. And as well, if you have any comment.
Thank you very much, Christine, for a very interesting overview of lots of activities. There are questions for Christine, and maybe we can ask first the audience in the room to ask questions and, and ask the people online maybe to raise their hand. Rene can give them the right to talk just now. So please, from Christina to Christina.
I find it very inspiring that you really, well, the different activities have something for students, something for school teachers, school learners. I think one aspect that that is important in South Africa is you have the parents of the school children who don't know where physics belongs and what it can do. So there is that other step that you have to talk to really the community about physics and inspire them about the value of that. Maybe you could comment a bit on have you, or what maybe successes that you had in really the parents or the community, so that they can support the children to take science in school and to study further in science. Do you have any comments?
I mean, the comment would be, when you're a kid, this is one of the things which is fascinating. This is the curiosity. So how they can play as well, how they can understand. I mean, just this image here, for instance, that's one of the things that I would say every kid would be curious on how they could, or we could explain as well physics thanks to that. All the geophysics as well, how the stars are formed, how all those different aspects as well of understanding and playing. Like if you're an accelerator, you know, you can think that you go faster and faster if you're pushing faster and faster. So this is what can bring us. So from what you need to do in terms of what they can learn as well at school. And this is why we try to show as well the teacher how important it is, keep them as well thinking in a creative way. This is, I think, where we can explore, adapt it to the community as well, so different way as well of saying. So this is why as well, it's not easy for having a global way of teaching. So of course, a teacher in America or a teacher in Asia or a teacher in Africa would have another culture. So this is providing tools and then thinking as well, also multidisciplinarity. So that's one of the things which is important, to involve as well art, or to involve as well, like it could be through cooking, it's chemistry as well. So that would be as well for understanding. There are a lot of different like storytelling. I think in Africa, that's one of the things I've been amazed by, all those wonderful stories. So we can, and this is one of the things we tried in our learning scenario, for instance, to bring an understanding on why, or the journey, for instance. So we have one of those book. I mean, again, if you look on the 16th of October, you'll see more, the race to the space. How can a student learn more as well from being in this cosmos, or what he will look at? So, and again, with the teacher to try to think among them, and thanks to some of the material, develop those scenarios that would be adapted and agile as well for their own audience and their own learner. It really depends on the culture. So,
are there further questions? Yeah.
I would be curious, what would be your comments on the examination system, which often is the reason why children hate either physics or mathematics. For instance, in South Africa, many principals encourage parents to keep their child in less intensive mathematics class at the end of the school, because then they can get better marks. And you've talked a lot about storytelling in physics and how it can be fun and so on. What is your opinion? Should we move away or not from the traditional examination system, which places much more emphasis on remembering technical knowledge and having a broader, bigger picture intuition about the subject?
so that's interesting because I'm French. I can tell you that the French system is very different than the American one. So how do we engage and how, or what would be the best way? So in France, it's really elitist. It means you have to provide, I mean, all the different, the perfect thing. In America, the opposite, it would be like, indeed, you have more project oriented and the student would work together to have the common grade as well. I have to admit that I really like this American way. So maybe it's one of the way how not to be too strict, but how to encourage the teamwork as well between the learner or the student, because they will have to see that later on in life, they have to be able to cooperate, not to stay. Of course, you do a PhD, you have your expertise in one domain. Doesn't mean that you can have your own company because you don't know anything about the economy or those things. So this multidisciplinarity is really what I would always prefer, to encourage sharing so with the others, and not to be, to encourage, that's the thing. Instead of having like CD, but we need excellence still. So see that it has to be also some way to control the level, of course. Teamwork is really what will make it work.
Thank you.
Questions from the audience here? I think, René, there was a question online. Okay, Magdalene, please, you're welcome to ask your question.
Thank you, Prof. The question that I have is, do you have any advice or basic guidelines that you can give to a postgrad that wants to engage young learners in primary and high schools with large scale projects in advanced research facilities such as at the SKA or CERN?
Eileen, can you please repeat your question?
Talk about from high school and how to give.
Hello, can you hear me?
Can you repeat? Because
I can hear you. Yeah, no, please, Magdalene, just repeat your question. It didn't come
Okay.
well the first time. Thank you.
So I wanted to know if you have any advice or basic guidelines that you can suggest for a postgrad student who would like to engage young learners in primary schools and high schools to actually give them sort of an introduction to the large scale projects that we have in advanced research facilities such as that at SKA and CERN.
yeah, that this is exactly the important thing in Africa. You have the SKA, you have connection to CERN. So if any postdoc would like to be engaged in that, for instance, to follow as well those courses, because that would be giving as well idea in terms of how to get involved. Again, now this would be to teach for younger, but if those postgrad as well want to be part as well of this ASP community, so this is where I think it would be really good to contact us with the African school. And for instance, those postgrad could be as well in those conferences that we are running, so every 2 years. So they would be more than welcome. So it's always important to have a good distribution, so through Africa as well. SK, yeah, so that's really important, and CERN, same way, so we have a lot of material there.
You have a comment, Christina?
Maybe
the
I
web
can
page.
follow up on the question, because I think she has been saying there are postgrad students, they are still students, but they are interested to reach out to children. That is what you get, and we also have that in our department. Our postgrad students say, we have made it up to here, but we want to go back to schools and go and speak to the children and say, this is exciting what we do. And we find it enormously that students go to the schools, because there isn't this age gap. They can talk to the children. They know what it is to be in school. They can inspire them. And so we, and in our department simply, we are not part of a big project, but we find it very, very good too. So our students have formed student chapters of the Optica and the IEEE, SPIE, yes. And from that, they get little money, not much. They get some money. They can rent a little bus, and have just now been out to different schools, and they go there with optics and physics demonstrations. So maybe it's something we can propose, because that's something that works in Africa. Young people talking to young people, and maybe that is what previous speaker has also been asking. What can you do? So we find that those student chapters really enables our students to go out, and it's not a lot of money. It's kits with demonstrations, and it's something for petrol, and they go out and they go to schools, and we believe we see the results of that in terms of learners at least taking science in school and then being able to get to university. That's a comment more than a question.
Which is completely also in line, for instance, in the conference where we were last week. From Zambia, we had one of our former alumni, so postgrad as well, doing exactly the same thing in her country. And this is why I think what would be great, again, networking to try to understand, because we have more like 1,000 different students as well that we connected to, could be as well those ambassadors in their own community. And again, this is maybe not teacher, not like a teacher like that accredited for having the pedagogical approach, but that have this know-how being as well in this our community in one sense. That could, I think, help a lot. Stay connected. Yeah.
Thank you.
Okay, thank you so much.
We have more questions online from Hannes Zil. Hannes, please, you're welcome to ask your question.
Man of the high school. So the idea is, so if I read, so decide to reevaluate the South African physical science curriculum has not evolved for a great number of years, and how the large barrier to the high school curriculum, so are the university courses which dictate the requirement for high school grade 12 graduation requirement. So can you provide insight into what she thinks in terms of the best challenge for the curriculum in South Africa? So indeed, we saw this as well when we were in Namibia. So we had as well the education and then the research, the different governance as well together. And we see that there is a gap there, clearly. So maybe one way is exactly that, to have those postgrad as well students being much more involved with the high school, and to try to give project as well for building up something together as well, where they can learn and they want to go there in those different syllabus as well. The syllabus has to be adapted. This is one of the things that we were looking for in Europe, but again, adapted to the European culture, but in Africa, so that is the same thing. Again, with the people that have this this will to build it up. So that's, yeah, to fill this gap. This is a challenge for sure, but to bring more at the university. So again, this is why this teaching teacher has been pushed up.
Thank you. And I think we have Lawrence Norris online with a hand up. Lawrence, please, if you would like to ask your question.
Please.
Okay, it doesn't seem to work. Our own. Please, Emmanuel, you're welcome to ask your question.
Can you hear me?
Yeah.
Yes, we can hear you. Please go ahead.
Okay, so I want to ask the facilitator if she has any experience combining coding with teaching physics in maybe high school in order to enhance the interest of high school learners in physics. That's my question.
The question is about experience with teaching high school kids again.
So my own experience.
Yes, sir.
Yeah,
Yeah.
well, this is a good question because I'm in the research side. I've been teaching to some of the high school in and through this African school. So this is where you can see maybe as well the difference, but I've never follow, the pedagogical tools and all those way as well of doing. So that's why I think it's important as well to understand from the different community.
Thank you. And time and considering that there should be some snacks outside, let's thank the speaker once more. Thank you very much, Christina, for your trouble to coming to Stellenbosch and to giving us a nice presentation. Thank you.